Okay, so here we have one more example of how to factor a trinomial. So remember, before it comes to factoring anything, the first check that we want to look for is, do we have a greatest common factor? So again, we need to look at our coefficients. So compare all your coefficients in all three of your terms. So we have a 2, a 4, and a 30. And looking at a 2, a 4, and a 30, we need to think, do we have something that is in common with all three of those numbers? Is there a magic one number that I can divide out of all three of those? The answer is yes, because taking a look at 2, 4, and 30, they're all even numbers, which means they all have a factor of 2. So I know that I can at least divide out a 2 from each one of these. So that would actually be my greatest common factor as far as my numbers were concerned. It couldn't be anything bigger because my smallest number here is a 2. I can't go over that. So as far as my numbers are concerned, 2 is my greatest common factor. Taking a look at the variables then, we need to first see, do each one of our terms have that variable in it? So let's see. We have an x cubed, an x squared, an x. They all have an x. Now what the rule says about variables is this. As long as each term has that variable, the greatest common factor is the one with the lowest exponent. So we need to take a look at the powers then. So in the first term, we have a 3. In the second term, we have a 2. And in this last term, remember, if there's not 1 there, it's understood to be 1. So the lowest one out of these is the x to the first power. So I'm going to take that x to the first power. This means our greatest common factor is 2x. So because I do have a greatest common factor, we need to factor that out of our trinomial first before we can do anything else. So let's go ahead and divide it out. So remember, in order to factor out the greatest common factor, what we're essentially doing is we're pulling out that greatest common factor out of all of our terms. We're going to scooch it over here to the front. But in order to figure out what our simplified trinomial would be, we actually need to divide it out from each one of these terms. So we're going to take our trinomial and we're going to do 3 little quick division problems. Now remember, in order to do this division, we need to know the quotient rule. We would divide our numbers like we would normally know how to, so we would do 2 divided by 2. But when it came to our variables, we would use the quotient rule. So let's go ahead and take care of the division. 2 divided by 2 is a 1. We don't need to write that 1. X cubed divided by x, the quotient rule tells us to subtract exponents, so 3 minus a 1 would give us x squared. Drop down our sign, we have a positive here, a plus, so we would do 4 divided by 2, which is a 2, and we would do x squared divided by x, so that's a 2 minus a 1, leaving us with 1, so we would have x to the first power. Drop down that minus sign, next do 30 divided by 2, which is 15, and over here we would have 1 minus the 1, which is 0, or also remember, anytime you have the same thing over itself, it's going to cancel out. So therefore, when we factor out the 2x, we are left with x squared plus 2x minus 15. Now we are not done yet. We have factored out the greatest common factor, but what we need to do next is we need to take a look at this trinomial that we have here and see if we can factor that. Now, if we can factor that trinomial, well, let's see, we have a leading coefficient of 1, right? So that makes this a little easier for us. We could go straight to drawing our parentheses here. Now remember, this first term here, this x squared, comes from multiplying the first times the first. So we need to think, what times what is going to give us an x squared? And the only thing that's going to make that happen is an x times an x. X times x is x squared. Then we need to move our attention to our last term, the 15. And we need to think, and we need to list all the different factors of 15. So what can multiply to get 15? 1 times 15 is 15, and 3 times 5. That's about it. So remember, what we need is we want the combination that multiplies to get our last term, but adds or subtracts to get our middle term, which in this example is a 2. So taking a look at our two different set of factors here, the only thing that would work is the 3 and the 5, right? Because 5 minus 3 is a 2. So I'm going to put the 3 here, and I'm going to put the 5 there. The next thing that we need to take a look at is our signs. So taking a look at our signs for a second here, we have a positive 2x and a minus 15. Now remember, the rule says that our numbers need to multiply to get the last term, but add to get the middle term. So 3 times a 5 is a 15. Now, I need to get a negative 15. Better yet, we actually have our rule that says whatever sign the middle term is, our bigger number has to have it. So our middle term is a plus, which means out of the 3 and the 5, 5 is bigger, so we need to give that one the plus. So in order to figure out what goes over here in between the x and the 3, it can either be a minus or a plus. So is a negative 3 times a positive 5 a negative 15? Or would the positive 3 times the positive 5 give us a negative 15? Now it would need to be the minus. A negative 3 times a positive 5 is a negative 15. And also a negative 3 plus a 5 is a 2. So now that we're done factoring our trinomial, we are finally done with this problem. So it's factored into this 2x times x minus 3 times x plus 5.